Now I would like to explain about my experiment, that is single degree of freedom of free vibration. Why we call it as free vibration? Because there is no force, there is no external force applied on the system, and the sensor used is LVDT. This is LVDT, or we call it as linear variable displacement transducer. The function of LVDT is to measure the displacement of the system.
Assalamualaikum, my name is Muhammad Rafizi. This is our experiment, our test rig. The title is 1 degree of freedom for free vibration system. 1 degree free vibration system. From this experiment rig, our group need to achieve 3 objectives. Firstly, our group want to find the stiffness of the spring. Yes. Secondly, to find the decay rate relative to different mass. We have 4 mass, which is 5, 10, 15, and 20 Newton. And then thirdly, our group want to compare the theoretical value, okay, with the experimental value from this experiment, which is the stiffness and decay rate. We want to compare between the experiment and the theoretical.
Good morning. My name is Muhammad Zul Hafizul bin Daud. I am the second presenter of this group, and I will present about experiment apparatus setup. First, because of this is 1 degree of freedom for free vibration, it consists of 1 spring, and the parameter we conduct in this experiment, we use 5 Newton, 10 Newton, 15 Newton, and 20 Newton. We use LVDT sensor to measure the displacement. So this LVDT sensor will go to DAQ system. This is DAQ system, and let's see the layout that we make. First, we use data analog system. Then go to scaling. This is to make sure the scaling, to make sure the graph is start from 0, and we use digital filter to filter the graph. Let's see. We set the limit frequency 5 Hz. That means only the 5 Hz, below the 5 Hz, 5 we use okay. Now we set the limit frequency is 5 Hz. That means only the frequency below 5 Hz will be measured. Then click OK. After that, we go to next scaling, and another one scaling, and we place the displacement over time chart. Then we go to data override to get the data in document. We also place the decay rate to measure the decay rate of this experiment. Okay, thank you.
Briefing about the layout of this lazy lamp we use. So this is the lazy lamp we use. So in order to find result or record result, we use what data set. So I have briefed that before. So continue. I use 5 Newton of mass, and I change it to the layout form. So bring this. So we get there. So there is no motion right now. Start this game first. There is no force acting on it. There is a disturbance. So start it. Okay. We can see that this is the displacement of the mass now, and it is decaying to the rest, to the zero position. So in theoretical, there should be no waveform. There should be no decay as far as doesn't have damping. So we started 0.5 kilo of mass. So we run small here. Set should be now. Okay, we run it again. Should be. So we run it. This using working model 2D. So you can see short wavelength, and if we increase the mass, you can see high amplitude of bump. So back to the experimental. Now we see 10, 15 and 20 of mass. So okay, look at this. It's still running. It's left before it's to become steady state. It's steady state now. So we run it. As the mass increase, it takes higher amplitude and longer time to decay.